started out with the squaring function, basic parabola. Excuse me, your basic parabola. Then it did two different things. It has a 1/2 out here. This 1/2 gives us a vertical movement. The 1/2 changes the distance of y to 0. So if it was 1, 1, 2, 4, it's now going to be 1.5. So this is going out a half. So actually, this is the wider one. It goes like this. But we still call it a vertical shrink because it shrunk the distance to 0. Don't get confused with the graph of it. It looks like it's stretched, but that's a horizontal stretch. But it's a vertical shrink. And vertical is all you need to get for this. This guy has a vertical stretch here. They refer to this one when it's in parentheses as a horizontal. We can still call them verticals. Because the number is greater than 2, greater than 1, we're just going to call it a vertical stretch. If you wanted to call this a horizontal shrink, you'd have to say by a factor of just flip to a fraction. But you can leave everything in terms of verticals. And I'm fine with that. Okay, this one, you see this in Algebra 2 a lot. What is my function? This function is this little piece of graph. Work off the graph. What is it asking me to do? It's asking me to take this function. If it was x squared, I would take all my values and I would move them up 2. So take this thing here, move everybody up 2. I wrote the coordinates down in case it's hard to see on my graph what they are, so I just wrote the coordinates down. Logan, question?
What do you call did you say what it's called when you make it?
When it's in parentheses, which one are you looking at? When it's wider? When it's wider, it's actually a vertical shrink because it shrinks the distance to 0. When it goes like this, it's a vertical stretch. Because it's actually changing it, it's making the distance to 0 bigger. It's stretching the distance from 0. That's what it's actually doing. It has a weirder look to it, and everybody gets confused because of the look. This one says just take a reflection. It's the y is changing, so the y is going from here to here. And you can see your reflection in the x-axis. I wrote the points down in case you need to see the points. Okay. And again, if you use your coordinates, just write the rules down. A reflection in the x-axis, the xy, the x stays the same, the y changes the sign. Okay with these? Stop me if you have any questions.
How do you know the parent function?
In this case, this black line is the parent function. So that's this. That's your f of x. That's this. That's the f of x. That's this. So normally, this will say x squared. And we take a parabola. We know this is our parent. Because there's only a couple of chord graphs that we use. We use a squaring, a cubing, absolute value, a rational, and a square root. So we just start with basics. But now, what they did here was, that the other one's a little easier to see, they did this. They set it out here. So what is my function instead of an x squared? It is this black line. Just this part right here. So now they want you to take that function, the f of x, this one, and move it 2 horizontally to the right. Just shift it over 2. So let me ask you something. This original function, what's the domain and the range of this original function? Not all round numbers, this black line right here. What's the domain?
No, 0.
0.
2, 4.
Everybody see that domain? Starts at the 0, ends at the 4. Just box this in. Let's just pretend this is a box around this. Okay, what's the range? -1 to 2. Okay? And everything that happens in between there. Okay, so now, I did this. I moved this horizontally 2 units to the right. What changes, my domain or my range? Domain. It's an X movement, right? It's next to the X. So I'm shifting horizontally. So I'm moving everything 2 units. So now, just looking at this domain, 0 to 4, where's it going to go to? What's my domain going to be? 2 to 6. I'm going to add 2, add 2. Isn't everybody going to move over 2? I'm just going to go 2 to 6. And my shift is 2 to 6. See it? See it? It's just a domain shift. That's all it did. It shifted everybody to the right. It moved, it slides it horizontally. So the one that affects the x-axis is the domain. Okay, say I did this. I started here, 0, 4, and -1, 2. Now where's my movement?
3 to the left.
3 to the left. So I'm horizontally sliding everybody to the left, right? What's my new domain going to be?
-3 to 1.
-3 to 1. And let me see if that's true. -3 to 1. See it? Picture your slides. It's taking whatever is there and just walking it 3 places over. So your domain changed. When we do a parabola, does our domain change on a parabola? No, because our domain was all real numbers. But our range would change, right? So it has an effect on the range. So if you move anything across the x-axis, the domain is going to change. If you move anything over the up and down in the y or over the y-axis, then the range is going to change. Get a feel for this. Really, move your hands around. It's what helps you the best. If you have this, you slide it over, just go with your hand, just move it over like this, like you're physically moving it. You're going to say, oops, I just moved everything off my x-axis and I changed it. Okay, these were coming up with your chord graph. So it came up, you had to find your chord graph, your parent graph. Your parent graph is a squaring. And sometimes it's easy to remember your parabola. Like if you, I know one of my sons always plotted his parabola by points in his head. So he would do this. He would always say his parabola went -1, 1, -2, 4, 1, 1, 2, 4. So he was always going 1, 1, 2, 4, 1, 1, 2, 4. And that's how he always started his basic parabola. So I can tell right here, here's a movement of 1, 1, isn't it? Even though it dropped down, but it's a movement of 1, 1. So that's my basic squaring function. So I start off with an x squared. And what happened to this guy? I dropped it down 1 unit. They kind of give you a little bit of the coordinates because what happens between 0 and 2? Well, there's your -1. So it gives you a little of the points. So this is the equation for this. Were you able to see it, right? Right? Okay, so this guy, absolute value. And again, absolute value is a 1, 1 all the way up. Go up 1 over 1, up 1 over 1, up 1 over 1. To kind of get your pattern that way. So now I have a shift this way. If you can see it pretty well, it's 3 over, if 2 over. If you saw 3, whatever you saw on it, as long as you gave me the shift this way with the plus. I don't know how good it comes out on your paper. So here's a horizontal shift off from my original one. Horizontal shift left. And a horizontal shift does not affect my domain. A vertical shift affected my range. So we see that? Everybody has this on their paper. Okay. These guys, this probably was a harder one to see because it has a reflection. This thing down here, we really didn't do anything that had that. We did the one that had the little arm that went like this. So this had a reflection. So you're going to reflect it, and then you're going to shift it. So I reflected it. Technically it went here, from here, and then I shifted it up one. The order does matter. Well, yeah, in this case it does. Because if I shifted it up one first and then I reflected it, or if I shifted it up first, then I reflected it, I'd be down, a little further down. And this one it does. And you really don't get a choice because you got to put that negative out there anyway. You could write this like this. You could write it with the one in front. Because order of operations is still going to do your reflection first before you add one. And sometimes in your book you see it written this way. But what I would do when you see this is take this guy and bring it back over here. Because it makes more sense to see the +1 at the end. This was a cubing function. For some odd reason, it's facing the other way, so there's where your reflection comes in, and it's got a shift. It's got a reflection and it's a shift. Whatever changes the direction of it is a definite reflection. Okay, and then these guys just had to draw this, and I guess you just had to draw it and describe the transformation. So this is a reflection. Make sure you're using the right verbiage for this. I want reflections, not flip over. I want horizontals and verticals. I want stretches and shrinks. This one has no effect on this. It's a reflection over the y-axis because it's next to the x. Just move your finger like this. It becomes the same graph. I tend to write the rules down just because I like to see the rules on these. The hard one, I know the hard one is the rational one. It came off of your original graph, this one. It had two sets of asymptotes, and all it did was negate it. So technically, it negates the reflection, which it doesn't really matter. It's going to come out the same way. Where your reflection goes here, with the negative x, it'll be reflected in the y. Even if you reflected it in the x, it comes out the same way. So if you made a mistake and reflected it over the x, you're still going to get the same graph. And that one has a smaller factor than 1, so that's called a vertical shrink by a factor of 1/4. And when you're doing this, this is important. Do I put it inside of this or on the outside? What makes it go on the outside, not on the inside?
It's affecting the y.
It's affecting the y, so isn't my y distance getting smaller? So my y is smaller. If I put it in here, doesn't my y get bigger? Right? So that's the only thing you kind of have to pay attention to on those two questions. Questions at all? No? Okay. So what I thought we would do is I want to do some more work with this because I know these are harder.